Building system: 100-unit single-story houses in Parit Raja, Johor. TS Dr. Muhammad Fikri bin Hasmori. Group members. Company background: Green Company Sdn Bhd. Address: Lot 103 Jalan Kencana, Taman Purau Kencana, Seri Gading, Batu Pahat, Johor. Incorporate 11 February 2014. Organisation chart: There has project manager, civil and structure engineer, structure engineer. Company location: In the circle, they have Jalan Kencana, company location for this project. Project background: Project name: 100-unit single-story houses. Project description: living room, 4 bedroom, 2 bathroom and 1 kitchen. Location at Parit Raja, Johor Darul Takzim. Cost RM 215,000 per houses. Project area: total land size is approximately 10 hectares, which consists of 100 units of single-story houses. Project location. Construction method justification: For this project, industrial building system methods are used for wall, beam and truss component of the building. For the project of 100 units of single-story house in Parit Raja, Johor. Precast concrete load-bearing wall panel are used for wall. Precast concrete beam are used for beam component. Duplication steel trusses are used for roof component.
Bismillahirrahmanirrahim. So for my part, it's a proposed drawing. So the drawing of our project: top elevation, front elevation, back elevation, side elevation. This is our top elevation of the whole project site. Side elevation, 3D layout, and the 3D view of the whole project site. So for our type component that used in our project, we have using 4 type of element, which is roof. We are using the prefabricated steel truss. Element of internal and external wall using the precast concrete load bearing wall. Column, we are using in situ concrete using the steel formwork, and the element of beam, we using the precast of beam. The type of the connection that we use, which is connection between truss and truss at the corner, connection between truss and truss at the intermediate, connection the beam and the column, connection between truss and the column, connection between wall and the column, connection between column and the foundation, connection between wall and the wall at the intermediate, and lastly, connection between wall and the wall at the corner.
Next, I will present for the details components and the connection. This is the components of the building and its ideas. For the wall components, precast concrete load-bearing wall panels are used. For the advantages, a low maintenance structures, good fire resistance, save time and money, and can be designed to be reused for the future building expansions. For the column, in situ concrete by using steel formwork are used. For the advantages, it has more strength, have uniform size and subsurface, and steel formwork are stronger, durable, and have longer life than the timber formwork. For the beam components, precast concrete beam are used. For our project, the rectangular beam, L-shaped beam, and inverted T-beam are used. This is during construction situations. For the advantages, fewer joints are needed due to longer span, and at the same time, it also reduces in the force work and the structuring cost. For the roof component, prefabrication steel truss are used. This is uncomplicated roof components, and this is complete steel truss. There are some advantages: can save cost and time, and at the same time, inexperienced carpenters are also able to construct the truss, and less labor costs are required. Next, this is the type of connection of the components for this project. For the wall-to-wall connections, case in situ joint and the distributed load angle are used. This is the corner connections, and this is intermediate connections. For the wall-to-column connection, welded joint and the anchor plate are used to join. For the beam and column connection, the tension and shear joints and the compression joints are used. For the column to the foundation connection, drive plates and the screw anchor and case in situ plate are used. For the trusses connection, the cogs are used to join the continuously by split plate connections, while for the diagonals and the posts are connected to code by welded gauge plate on the codes. For the truss and the column connections, rigid connection is used to bolt the trusses and the columns together.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Arshad. I will discuss about my part which is IBS core calculation. For part 1, structure system, we get 45 IBS core. And next, for part 2, which is wall system, we get 20 IBS core. And part 3, other simplified construction solution, we get 19 IBS core.
The flowchart highlights the general process of IBS component for project initiation to completion. First of all, the project identification, and then estimate and project award, and then final design where the calculation, erections, drawing and detail. Next is submittal and approval process where the manufacturer, store and transport. Generally, the IBS component will undergo fabrication in the factory. For the project of 100 unit single-story houses in Paya Raja Johor, the wall internal and external is using precast concrete load-bearing wall panel. For the beam component is using precast concrete beam, and for roof component is using prefabricated steel truss. After undergo fabrication process, the component will be transportations and delivery to the construction site. The specialist installer will check the condition for damages. If any, the precast component will either return to factory or repair at construction site. Before the construction start, the site clearing should be done for preparation of foundation and casting the in-situ column stump using steel formwork. After column done, installation of precast beam slab will take part by starting the setting out, wall positioning, wall adjustment and beam setting out by using clamper or lifting bell. Next is installation of truss, waterproofing at external joint and wet area, mechanical, electrical and plumbing fitting. And lastly is finishes by surface treatment such as grooving, surface coating and many more. And lastly is erections and fill finishes by joint inspection for partial handover.
As conclusion, the IBS score of this whole project is 84%. The value of IBS score is sufficient for the requirement of the CIDB Levy assumption as a private project need to be more than 50% of IBS usage. IBS help to reduce time and cost in the construction progress management. It hoped that IBS method can be implemented for the future construction. Thank you.